Welcome to May 21st LeetCode Challenge, Coin Change. You're given an integer array of coins representing coins of different denominations and an integer amount representing the total amount of money. Return the fewest number of coins that you need to make up the amount. If the amount of money cannot be made up by any combination of the coins, return -1. You may assume that you have an infinite number of each kind of coin. So we're given the array of integer coins here. We have 1, 2, and 5. We want to make up the amount of 11. So basically, we want to know how many coins you need to make up the amount of 11. So to go about this, you take 2 coins of 5 and 1 coin of 1. Therefore, you have the sum of 11. You have a coin of 2. You have an array of integer coins of denomination 2, and you want to make it the amount 3. Well, you see that if you pick 1 coin, it'll be 2. If you pick 2 coins, it'll be 4. So you can never make 3 from this coin array integer set with the denomination of 2. So therefore, return -1. If you have a coin array of 1 and the amount 0, obviously you can just return 0 coins because you don't need you don't need any coins to make the amount 0. And you have the constraints being the length of coins between 1 to 12, and each index I of coins between 1 to 10 to the 31st minus 1, and the amount is between 0 and 10 to the 4. Alright, so in order to do this, there's a couple ways of doing it. Obviously, recursion and memorization as well, but those are kind of long and hefty. I'm going to go with a dynamic programming approach. So in order to do that, let's say we have a dynamic programming array, and we want it to be all -1 first times the length of, so we want it to be so assuming the coins have a denomination of 1, right, and the amount is the highest you can go, if we were to take the amount of coins there, that means that if we take 1 as the amount, 1 coin as the length, and we take the amount as the bare minimum, we know that we're going to need basically 1 coin times amount, the number of amounts we need. So therefore, I'm going to make my array the length of amount plus 1. Right? That's going to be the dynamic programming array. So initialize the dynamic programming array table with -1, which means that you have no combinations. Basically, we take out 1 each time of length amount 1. If each we have a denomination of 1, if that's the case. Next thing we want to know is we have to initialize dynamic programming array at index 0 to be 0. So this is the base case. So basically, you have 0 coins needed to take the sum of 0. Okay. Next thing we do is iterate through and build all the amounts from 0 coin to the amount number. So in order to do that, we do a for loop for I in the range of amount plus 1. We are going to update if the dynamic programming array at index I is not equal to -1. So we need to skip the ones that we cannot sum up to I, therefore the amount. So we need to skip those. If that's the sum of the dynamic programming array table at index I is not equal to -1. So we need to iterate through each coin and update the dynamic programming array. So for each coin in coins, we need to iterate through every coin and update the dynamic programming array if I, index I, is plus the coin amount is less than the amount plus 1. This means that we make sure that every index is not out of the range of coin amount, the amount I should say. And then we want to compare to see, update the dynamic programming array table. So what we're going to do is if dynamic programming array I plus coin is equal to -1, or dynamic programming array at I plus coin is greater then the dynamic programming array at index I plus 1. Then we need to update the dynamic programming array at index I plus coin. Oops. To be dynamic programming array at index I plus I. Plus 1, I should say. That's the amount of coin needed. So at the end of all this, for loop, we need to be able to return, as in any other dynamic, return the dynamic programming array at the last index. The last index is going to be the amount taken here. Okay, let's run this. Alright, submit. So from inspection, we see that hopefully this gets accepted. Oh, that's actually pretty quick. So, it's actually a great code. So what we have here is basically time complexity is big O of n times m, where n is the length of the coins, and n is the amount. So m is the length of the coin, and n is the amount, so it would be big O of m times n. Space complexity, we store everything in a dynamic programming array of size n. Therefore, n is the amount as well, because we're taking everything of amount plus 1, which is a big O of n. Alright, for memory usage, I should say. Alright, that is all. Have a great day, guys.